everyone, today I'm going to explain Lab 7 Activity 1, which is about socket programming using TCP in Java. In this activity, we create two programs, a server and client. This one server and the client. We create two programs that communicate with each other. So what's the purpose? Communicate with each other, the communication with each other through sockets. The server program, this one, first, first what we do in the server program, first create a server socket like this. You all know the Java syntax and all that thing. So on the public main, like we will make a server socket on the port which is 1234. Let it wait for the connection from the client. When I execute it, the server program first. So make sure like we will execute the server program first. Like if I execute it, it will show like server is waiting for the client. Then it waits for the connection from the client. When the client connect, the server accept that request and set up input and output stream so that both can send and receive message. And the client program connect the server. Like if I run the client program in the new terminal like this, like if I run the in the new terminal, the client program, it will show that enter message for server. So let me write here like hello, hello server, it's me, Hassan Khan. Like if I press enter, server reply hello client, I receive your message. So let me go to the server terminal where I just received the message. Yeah, here is it. Server is waiting for client. Client connected. Client say, hello server, it's me, Hassan Khan. This proves that the TCP socket connection is working properly between the client and the server. TCP provide reliable and the connection oriented communication, which means that the message is delivered in order and without loss. So the message here in the server shows that it's reach here without any loss. So this is activity one, and that's all. Thank you. So here is lab 7 activity 2. In this video, I am explaining lab 7 activity 2, which is about UDP socket. As basically it's all about the UDP socket programming in Java. Unlike TCP, UDP is connectionless protocol, which means there is no permanent connection between the client and server. Like each message is sent as a independent datagram packet. Like first the connection is built in TCP, but unlike the TCP, it's not happen the same in the UDP. It's a connection less. So in this activity we have two programs like UDP server and the UDP client. The server create a datagram packets. Like the server create the datagram packets. The server creates a datagram socket on the port 9876. 9876, you can see here. So when I run the server program like this, it will show UDP server is running. Now it is waiting for the client. So when we run the client in a new terminal, like client says like enter message for the server. Like we say hello UDP server. It will send instantly without any wait. Server reply message received hello UDP server that I sent. Now we go to the server terminal. Here the message received from the which say the client says hello UDP server. So what it proved like from this? When I run the server, it shows that it's running and waiting for packets. Then I run the client, type a message like hello from UDP client or hello UDP server, And you can see the server receive the message instantly and reply to the client. This shows that how UDP allow fast connectionless communication through it does not guarantee delivery like TCP. Thank you. So now this is the lab 7 activity 3, which is about reliable data transfer RDT. So reliable data transfer using UDP, which is connection less protocol, also called RDT. As we know, UDP is fast but unreliable protocol packet can get lost or arrive out of order. So in this activity, we simulate reliable data transfer by using acknowledgement. We send the acknowledgement and timeouts just like a TCP. Here we have two programs like RDT sender and the RDT Java. So the sender sends a message to the, how it's worked basically. What's better is that how it's worked. The sender sends a message to the receiver through UDP, which is faster but unreliable. After receiving, the receiver sent back an acknowledgement to confirm it was received. So how it will work when I run the receiver, like first thing first, I will run the receiver. I run the receiver, it waits for the incoming message. Like it shows like receiver is waiting for packets from the sender. So now I will go to the sender and I will open the new terminal here and run the sender. It will say enter message to send. Like I will say like hello Hudson. Now I will send the message. What it says package send hello Hassan receive acknowledgement for hello Hassan. Now I will go to another terminal of the receiver. It shows that acknowledgement has been sent. Has been successful. So this activity demonstrates that how RDT protocols ensure reliable delivery even over an unreliable UDP channel. So its credit goes to RDT. Thank you. So today I'm going to explain the Lab 7 Activity 4, which is about reliable data transfer 3.0. And RDT using UDP sockets is the UDP socket, but we are using the reliable data transfer version, which is 3.0, which is the latest version. So in this activity, we add another important concept, sequence number, to make our communication fully reliable. So to send attach, the so when I run the receiver first, it will show receiver is waiting for the packets. Then I run the sender and time some message like here. I run the senders in a new terminal. So I will write some message like hello RDT 3.0. I will run it. Send packet, receive acknowledgement 0. The sender send the package with acknowledgement 0. And the sender received the acknowledgement and flip the sequence to 1 for the next message. If I stop the receiver or delay it, the sender show a timeout message. For example, I will go to the next terminal like receiver. It shows like acknowledgement 0. This shows that demonstrate how TCP reliability is built conceptually using sequence number. So basically, long story short, what I'm trying to say, like sequence number add more reliability to in the TCPs. Conceptually, using sequence number acknowledgement and the retransmission are make the connection more strong, more reliable, more authentic, more secure. So basically, when we add the sequence number, it add the acknowledgement, like we know that acknowledgement is 0 or 1, and it also retransmit if if it is not if it is law, it can be retransmitted, so it work according to that.